Now there's only one bit left, this generate sequence, so let's talk about that. Now, sequence in this formulation is a function that takes x and y, two patterns, and what it returns is a function, and that function takes a list of numbers and returns a set of texts that match. So sequence is delaying the calculation. It's computing a function which can do the calculation later on. Genseq does the calculation immediately. It takes x and y and a set of numbers, and it immediately calculates the set of possible texts. Now the question is, what do we know about Genseq in terms of the patterns x and y and the set of possible numbers? We know at some point we're going to have to call the pattern x with some set of numbers. We're not quite sure yet what, and that's going to return a list of possible text. And then we're going to have to call y with some other set of numbers, and then we're going to have to concatenate them together and see if they make sense, if the concatenation of some x and some y, if that length is within this allowable set. Now, what do we know about what these n's should be in terms of this set of possible numbers here? Well, regardless of what this set is, so this could be a dense set, so we could have ns equals 0, 1, 2, all the way up to 10 or something. Or it could be a sparse set. It could be, say, only the number 10. But either way, the restriction on x and y is such that they have to add up to no more than 10. But x could be anything. If the list of possible numbers that we want to add up to is only 10, that doesn't constrain x at all other than to be less than 10. So this n should be everything up to the maximum of n sub s. And then what should y be? Well, we have two choices. One, we could, for each x that comes back, we could generate the y's, or we could generate the y's all at once and then try to combine them together and see if they match up. And I think that's actually easier. And so for the y's also, they can be any size up to the maximum. And then we take the two together, add up the x match and the y match, and see if that length is within n. So in this example, if ns is equal to 10, here we want to have the n's be everything from 0 up to 10 inclusive in both cases, and we get back some results, like say A, B, B, A, C, D, E, and so on, and some other results over here, A, B, B, C, D. And then for each of them, we add them up, and if we say ABB plus AB, and check to see if that's in NS. If it is, we keep it. If it's not, we don't keep it. So here's a candidate solution for Genseq. So we take x, y, and a set of numbers, and then we define NSS as being everything up to the largest number, including the largest number. So we have to add 1 to the maximum number in order to get a range going from 0 up to and including the largest number. So now that we know the possible values of the numbers that we're looking for the sizes of the two components, the x and the y component, then we can say M1 is all the possible matches for x, M2 is all the possible matches for y, and if the length of N1 plus M2 is in the original set of numbers that we're looking for, then return M1 plus M2. So this seems reasonable. It looks like it's doing about what we're looking for to generate all sequences of x and y concatenated together. But I want you to think about it and say, have we really gotten this right? And the choices are, is this function correct for all inputs, or is it incorrect for some? Does it return incorrect results? Or is it correct when it returns, but doesn't always return? Think about that. Think about, is there any result that looks like it's incorrect that's being formed? And think about, does it infinite loop or not? And so think about base cases on recursion and saying, is there any case where it looks like it might not return? This is a tricky question, so I want you to try it, but it may be difficult to get this one right.